So here's our quick announcement. Today we're covering this new section, equations of lines, and like I said on Friday, that section is not on the quest, which is coming up Wednesday, right? 2 days from now is our very first quest right here in this room, taking the full period. And so Montserrat here is going to talk to us about a wonderful service that you might take advantage of at some point in the next 48 hours in preparation for that quest. Montserrat. All right, so again, we're here on page 28, so let's jump up to the top of page 28 and start with this daily summary, and we'll go back to Cody. Thank you. Iman, number one. Thank you. All right, so to be really clear, there's no homework due on Wednesday. This homework that is going to be based on this material is going to be due Friday. I want you studying for this quest. It's important. One other thing about the homework. So my policy in the syllabus is that I will take homework up to one class late. So I will tell you that I'm even more generous than that. I will take any old homework up to the day of the quest, which is Wednesday. But after Wednesday, I'm not taking any of homeworks 1 through 5. Right? The goal of doing all the homework is to keep you in line with the course, and I don't want people to plan on doing like 4 weeks of homework all in one night. So, so I'll take any homework assignment up to the day of that quest, but after that I won't take it. All right, number 2, slope-intercept form. Perhaps this looks familiar to you. For a linear equation of the form y equals mx plus b, let's just pause right there. Raise your hand if you've seen that equation before. Y equals mx plus b. One time. So it's a pretty well-known equation. What does the m represent? Slope. Super. That's always the number touching the x. And what does the b represent? The y-intercept. And so that's written out there. We'll give you some color coding here. So m is the slope, and b is the y-intercept. So most straightforward question you could get based on that equation is here in number 3. It says write an equation in slope-intercept form, that's that, for the line that has a slope of -2/5 and a y-intercept of 0,3. So y equals something times x plus something. The something that goes in here is the slope. The something that goes right there is the y-intercept. So what number goes in yellow? -2/5. That's the slope. That's right there. And then what number goes in blue? It's 3, because 3 is the y-intercept. Notice the 0 is implied, but it doesn't actually come into the equation. It's only the y coordinate of the y-intercept. Okay? All right. So we're going to see in just a couple of minutes another equation of a line. It's going to start y minus y1. You might have seen that equation too. So how are we supposed to keep them straight? Well, look, the slope-intercept form involves 2 things, the slope and the intercept, the y-intercept. So it is named so that you know exactly what it is, what the 2 pieces of information you need to use it are. Okay, much tougher than number 3 is number 4. We're going to find an equation of the line that passes through those 2 points, and then there's a process outlined down below here which we'll follow as we do, okay? So we're finding an equation of the line that passes through those 2 points. This is a very common test question. Find the equation of a line hitting 2 points. Okay, so here's the process we will follow up above. It says circle both coordinates of a point on the line. If you have 2 points given to you, pick either point and circle its coordinates. So I'm just going to grab that first point right there and circle its coordinates. And then part B says write down the slope of the line, and this may require some calculating on your part. For example, you might have to use this y2 minus y1 equation to get the slope. So let's get the slope of the line connecting those 2 points. So we know the slope is the change in y's on top over the change in x's on the bottom. And so we're just going to subtract. Now I've circled 1 point, but it doesn't matter which one is circled. We need to use both of those points up there. So upstairs, I'm going to do 4 minus -5. Be really careful about your negative signs and your subtraction signs. You got to have them all there. As soon as I do 4 minus -5 on top, I am saying I'm subtracting in this order. So there's only one right thing to put on the bottom. What minus what? -1 minus 2. Just got to be consistent with your order on top and bottom. Okay. So this is equal to, upstairs is 9, right? 4 plus 5. Downstairs is -3. And it happens to reduce. It doesn't always, but this one does. Okay, so there's the slope. Questions on calculating the slope? All right. And down here in part C, it says write y equals mx plus b. We can. Back up here with the slope calculation. Yeah. So what we're, all right. Okay, so the next step is a funny one. What does it say? It says write y equals mx plus b. So we're just going to write it. The process that I've written down there is perhaps more detailed than many of you need, but in my experience, I found that it's really easy for some folks to get confused about the roles of these different letters. You got 4 letters in that equation. Some of them are going to be in the final answer, but some of them need to get replaced with numbers. But then other ones get replaced with numbers even if they'll change back to letters in the equation. So I'm writing something that's really detailed down there in case you need it. If you don't need it, it's no problem. But we've just done part C. It's really easy. It just says write y equals mx plus b. Moving on to D. In the equation above, the one that we just wrote, it says replace the m with the slope and write the equation y equals some number times x plus b. What is that some number? It's the slope, right? That's the number that we're putting in there. So all we're doing is copying this equation right here, but that some number is the slope. But there's still a y, and there's still an x, and there's still a b. So down here in the next line, y equals some number. It's the m. What's the slope? It's -3 times x plus b. So at that step, all we did was change the m to the slope. Again, this is more detailed than some of you need. I don't need you to go through this super detailed process if you don't need to. I just got to get you to the answer. So however you get there is fine. But I'm giving you a foolproof way, or at least a way I think is foolproof. And then there was something else there. It says put a star next to that equation. Again, lots of details in this process. Okay, moving along. We're now in part E. It says rewrite the equation from the previous step. But now we're going to replace the x and the y in the equation with the coordinates of the point that you circled in step A. We circled the point. We're going to replace the x and the y in the equation that we just wrote with the coordinates of that point. So let's do that. So I circled up there in blue, -1 and 4. So I'm going to put this here in blue. Instead of y, how much is the y at the circled point? 4 equals -3. We're just copying that equation in black times, instead of x, how much is x at the circled point? -1. Plus, how much is b? I don't know yet. We're going to find it, but it's just b. And again, this is why I've got this super detailed process, is because it can be really confusing which letters become numbers, which ones stay letters, and when do they happen? When do those changes happen? And if you take a look at what I've written down here in part E, it says that the equation we just wrote will say some number equals some number times some number plus b. The b is just there. It's part of the process. We need to find the b, and we're about to. Part F is going to be pretty straightforward. It says solve the previous equation for b. Okay, so this says 4 equals -3 times -1 is +3 plus the b. And then move that 3 over to the other side. So we get b is 1. Okay, and then we're just about done. Last step here. It says plug this value of b into the equation with the star. we put a star next to an equation, and the only reason I did it is so I could refer to it here. We're just going to go back to the starred equation, and we're going to change the b to +1. But the x and the y stay. Y equals -3x plus 1. And that's the equation of the line. So working through this example, you might see what I'm talking about here with the possible confusion about which letters become numbers, and then the x and the y, they go back to being letters, right? They were numbers for a little while, but now they're letters again. But the m and the b, they were both letters, and then they become numbers in different spots in the process. So if you like this process, practice with it a little bit. I think it'll become pretty second nature to the point where you really don't need to follow as much detail as I've got there. But if you ever have any confusion about finding equations of lines, then I'd encourage you to really try working through it in this detailed fashion. Any questions on that problem? Okay, last thing, and then the activities for today. Says in part 6, we can also find an equation of a line using another method. And it says, suppose that we've got a line that has a slope m, but this time it just contains an arbitrary point, x1, y1. We don't have the y-intercept in this case. We just have some random point. Then an equation of the line is this thing, y minus y1 equals m times x minus x1. Show of hands if you've seen that equation before. Y minus y1 equals m times x minus x1. Not near as many. And to be honest, this is actually a change that I have seen in my career as a teacher. When I was in school, back before electricity, there was like this y minus y1 was the main equation. Like I knew the y equals mx plus b, but this was my default. And over the course of my time teaching through the years, I've seen a shift from the equation that I grew up with to the y equals mx plus b, which is now really the primary one that folks use. So let's give this one a shot, and then you can decide for yourself which one you think is better. So this equation, not surprisingly, is called the point-slope form of a line because it involves the slope and a point, x1, y1. That was this guy. So we'll go through this much more quickly than we did the previous problem. So we're going to find the equation of the line that passes through the same 2 points, but now we're going to use this equation, just a different equation. So the first step is the same as the first step before. We have to find the slope. So I'm just going to copy the calculation again. You have to do it either way. So 4 minus -5 over -1 minus 2. And now we're just going to plug in to this brand new equation here. I'm going to circle the letters that are about to become numbers. y1 is a number, m is a number, x1 is a number, but x and y are variables and they're never going to change from x and y. So the equation becomes y minus y1. y1 is a y coordinate of any point that you have. I'll pick this one, but it makes no difference. You could pick the other one if you want. So y minus, how much is the y at this point? 4. Equals. The next circled thing in our green equation up here is m, which is still -3, times x is just plain x. It's a little bit different from the x that we had before. In the other equation, the x became a number. Minus that x1 is the x coordinate of the point we circled, which is -1. Are there any questions on what got substituted? Fiona? Yes? So yeah, the 1 is supposed to indicate that it's a very particular point as opposed to the variables x and y. Okay, so let's, I mean, like in theory, that's the end of the game. That is a perfectly valid equation of the line that we were after, but typically you solve the equation for y. So let's do that. I'm going to copy the left-hand side. I'm going to copy the -3. Inside simplifies to x plus 1, right? minus minus 1 is plus 1. And then what do we do with that negative 3? We got to distribute. There's no other thing we can do at this moment. So y minus 4 equals negative 3x minus 3, or plus negative 3. And then the last step, again, I'm trying to solve for that y, which means I got to move this minus 4 over by adding 4 to both sides. So y equals negative 3x plus 1. How does that equation compare to the one we got on the previous page? It's the same. So it's totally up to you. I'm never going to require that you use one version over the other, either the y minus y1 from this page or the mx plus b from the previous page. So really, it's much more important to me that you get really good at one equation than to be so-so at both equations. All right? I don't know. I don't know why the mx plus b became like the go-to equation for lines. Personally, I mean, this could just be my bias because it was how I learned it, but I still feel like this is the more straightforward equation to use. But anyway, whatever you want to do is fine. Just get good at one method, okay? All right, one last thing before the activities. A reminder that there is a sample quest in your packet just a few pages away. I think it starts on page 33. And on Moodle, you will find complete solutions in color. And on YouTube, you'll find complete solution videos, right? So you have lots of resources between now and Wednesday to use for that quest. Okay, but for right now, work on the activities and raise a flag if I can help.